Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 1-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to solve linear equations. So in order to start solving these, we need to acclimate ourselves to some new vocabulary. All right? So the first thing is one that you've already heard before, I'm sure, and that is the word variable. Oh, that was terrible. Let's try that again. So a variable is an unknown quantity. And in algebra, we tend to show that unknown quantity with the letter X, although it could be any letter, okay? It could be X, it could be Y, it could be S, okay? So a variable is just an unknown value. Now, an equation is a mathematical statement with two expressions that are set equal to each other. So notice how the word equation has equa in it. So if you have some kind of expression that does not have an equal sign, then you don't have an equation, you have an expression, and you cannot solve an expression. Now, in order to solve an equation, or to figure out what x is, you're going to have to utilize what are called inverse operations. So an inverse operation is addition, subtraction, multiplication, division, something along that line, okay, which undoes one operation. So for example, subtraction counteracts addition, and multiplication counteracts division. All right? The process of using these inverse operations are going to create what are called equivalent equations. So they're equations that are equal to each other, they just look a little different. Now the process of solving an equation means that we are trying to get this variable alone. Okay, so I'm trying to get to x equals some kind of value. We use the expression isolating the variable to describe getting x alone. And then finally, the solution of an equation is a value for which the variable which makes the statement true. So let's go ahead and take a look at what we have here. You have most likely learned about a process called Pemdas. Okay, where P stands for parentheses. Okay, it could also be parentheses or grouping symbols. So this fraction bar is a grouping symbol. The parentheses are a grouping symbol. Being underneath a radical is a grouping symbol. Okay. E stands for exponent. So sometimes you'll see a power, especially up here you'll see something. And so you have to deal with exponents. M and D tend to go together. That's multiplication and division. And A and S go together. That's addition and subtraction. So when we go to solve an equation, what we are actually going to be doing is working backwards through Pemdas. All right, so first I need to deal with any addition or subtraction that's kind of taking over things. All right, so this minus 8 is stopping me from breaking apart anything here in this kind of fraction. Now, Savvas gets a little quirky here. They resolve the fraction before they deal with the 8. I don't particularly like that. Usually if there's a fraction, I like to get it alone or to isolate it. It's kind of one of those you do you boo-boo situations though. The reason why I like to isolate this fraction or to get it alone is because I could multiply by 3 to get rid of the division of 3 that's here. And if I were to do it before I moved that 8 over and got 40, people tend to forget to multiply the 3 to this minus 8. So that's my attempt to kind of get rid of that chance. All right, so the next part I'm going to go ahead and deal with the fraction. Okay, that's a grouping symbol. Now, I need to get rid of multiplication and division as well, and that's what a fraction bar is division. This is saying I'm taking the expression and dividing it by 3. So to counteract the division of 3, I am multiplying each side of the equation by 3. So on the left-hand side, the multiplication and division of 3 cancel each other out, and I'm left with 2 times x plus 4. And on the right-hand side, 140 times 3 is 120. From here, I have two options. I could distribute to these parentheses, which is probably the most traditional thing. That's what I'm going to do. But I could also treat this as multiplication, and I could divide it to the other side of the equal sign. The perks of dividing by 2 would mean that I'm dealing with a smaller value here. Distributing, which I'm doing here, is actually going to be causing me to have extra steps. But it's still the more traditional route, so that's the one I'm going to go with. So here we are. So 2 times x is 2x, and 2 times 4 is 8. So remember, if you have a number or have a letter that is squished up against something, so it could be squished up to some parentheses, I could have it squished like to an x like this. Anytime you have something like that, this is multiplication that's happening, okay? Alrighty, so my next step here, if I look, I have multiplication and I have addition. So if I'm working backwards through Pemdas, I need to get rid of the addition before I could get rid of the multiplication or division. So this plus 8, the inverse operation I need to use would be minus 8, which gives me the expression 2x equals 112. And again, that 2x is multiplication. So to counteract multiplication, I'm going to go ahead and divide both sides by 2. Miss Caswell struggles with quick math, so I want you to think about this real quick. 112 is like 100 plus 12, right? And I know how to divide those by 2. 100 divided by 2 is 50. 12 divided by 2 is 6. So 112 divided by 2 is 56. Now, theoretically, if I take that 56 and plug it back in to the equation, I should be able to solve the left-hand side of this equation and get 32. So that's a way to check yourself. Let's go ahead and do this again here. So now they've flipped the side of the whole number versus this fraction, but it doesn't really change anything. So to get rid of this whole number that's trapped outside of the fraction, that 4 is being added to the equation. So counteracting that addition, I'm going to subtract 4 from each side of the equation. So I have 3x minus 1 over 2 is equal to 9 minus 4, which is 5. Now to get rid of this fraction bar so that I can break apart where this x is, I need to go ahead and counteract that division of 2. So I'm multiplying both sides of the equation by 2. So on the left-hand side, my 2's cancel each other out, and I'm left with 3x minus 1. And on the right-hand side, 5 times 2 is 10. So if I look at where x is, I see that x is being multiplied, and then that there's also something being subtracted. So if I reference back to PEMDAS, I have to get rid of the addition and subtraction before any multiplication and division. So to counteract the subtracting of 1, I'm going to add 1 to each side. Okay, that's going to give me 3x is equal to 11. And then 3 times x is what's happening here, so I'm going to divide each side by 3. Now notice my solution here. I have x is 11/3. So that's a little bit startling for folks because we're not used to seeing fractions as our answers. Now understand 11/3 is the correct answer here, and I do not want to convert it to decimals. Okay, if I take out my handy dandy calculator and do 11 divided by 3, I get 3.6 with the 6 repeating. So the most correct answer is this fraction here. So there you have it. That is solving linear equations. Until next time.